Assalamu alaikum. This is part 4 of this lecture, and in this part we are going to discuss mathematical functions, characters, and strings, and how they are processed using Java. So we'll start with mathematical functions. In Java, mathematical functions are all implemented in a class called the math class. So within this math class, we have all of the mathematical functions that we'll need to solve whatever equation that comes across us. And this math class is already predefined. You don't have to write this class, you don't have to import this class because it is already built in the java.lang package. So whenever you use this class, you don't have to import it at the beginning of your program. And you don't need to understand the details of what it means to have a math class and importing a class, but for now I just need you to understand that every mathematical function, every mathematical constant that you will need in this lecture, it is imported, or it is within the math class. So not only do we have methods in the math class, but we can also have constants. And examples of those constants are pi and e. So what are examples of the methods in the math class? We have 4 categories. The first is the trigonometric methods, such as sine, cosine, tan, cotan, and exponent methods, such as logarithmic methods, power, and rounding methods, if we want to round, floor, ceiling, and finally min, max, absolute, and random and pseudo-random numbers to generate. So all of these are in the math class. So we'll start with trigonometric methods. Trigonometric methods are in the math class. They provide all functionality for trigonometry. So examples of those functions are sine, cosine, tan, acosine, asine, and atan, which is short for arc cosine, arc sine, and arctan, which means the inverse of cosine, sine, and tan. And maybe you've learned it in a different syntax or different words. Maybe you've heard about cosecant, cotan, and secant. So these are just equivalent and different terms only. So the way that we write those in Java is we first write math, which is the name of the class, and then we add a dot, and then we write the name of the method. And then between the parentheses, we add the value that we want to calculate the sign of that value. So in this example, the sign of 0 returns 0. Another example, the sign of, and here it also shows you how to write pi. So writing the value of pi, we also use the math class, so math dot, and then capital letter pi because it's a constant, and then over 6. So here we want to find the sign of pi over 6, and the value returned is half. So this is the value of sine of pi over 6. And we have different other examples. Here we have another example using cosine, and we write it in the same way. Cosine of 0 returns 1, and other examples apply the same way. And we can also use tan, acosine, asine, and atan. Next, we'll learn about exponent functions, and we have 5 exponent methods. The first is exp. Between parentheses, we'll write the number that we want, the e to the power of a. So if we know what e is in math, so this function, or this method, as we call it in Java, it is going to apply this function. So e to the power of a, whatever we decide a is. So if we have exp2, then e to the power of 2. It will calculate e to the power of 2. If a is 3, it will calculate e to the power of 3. And log parenthesis the value of a, it will return the natural logarithm of a. If we write log 10, it will say that 10 is the base, and it will return the 10-based logarithm of a. Pow, we have two values. The first value will be raised to the power of a second value, and then the square root of a value a will return the square root of that value. The way we write these methods is, first we have to add the name of the class, which is math.exp, to return the e to the raised to the power of whatever value. Here it is a, so it will return the value of 2.71. If we want to use log, we write it in the same manner. Pow, it will return the 2 to the power of 3, which is 8, and other examples apply in the same way. So other examples of rounding function, we have ceil, floor, rent, round, and rounding with the long method. So with ceiling, x is rounded up to the nearest integer. So if it's even 2.1, the smallest value that we have in the rounding point, it will move it to the nearest integer. So 2.1 will be 3. And then floor will just ignore whatever is after the floating point, and it will round it down to the nearest integer. So 2.1 will be 2. And rent, it is very similar to rounding, but the difference is if it's between two integers equally close to both of them, it will round to the nearest even number. So, for example, if we have the number 1.4, what it does is it will round it to 1. If the number is 1.6, it will round it to 2, which is very similar to rounding up until now. But what is different between it and rounding is if it was equally between two numbers, such as 1.5, then in this case, it is equally close to 1 and equally close to 2. The rent function will return the closest even number as a double value because it returns a double. So in this case, 1.5 will return 2. But let's say we have 2.5, which is equally close to 3 and 2. In this case, it will also return 2 because the closest even number, or the even number between those values, is 2. So it will return that number. And then the rounding function, as you know, it will return the rounding of a value. So if it was 1.3, it will return 1. If it was 1.6, it will return 2, regardless of any other value. It only sees the cutting point, which is 1.5, and it will turn it to 2. And round function returns an integer, and there's also another function that will return a long if the value that was entered within that function was a double. So if I use a double in my round function, it will return a long integer, but if I use a float in my round function, it will return an integer. And here we have examples how we write them in Java. So it is the same way as we did with trigonometric functions. We just write the class math dot and then the name of the method, and it will return the result. So how to use min, max, absolute, and random? They're very easy. Max, you will give it two numbers and it will return which is the max between those. Min is the same way, and we write it in a similar fashion. So we write math, which is the name of the class, dot max, and then we write the two values. It will return the bigger of those two. And then we also have min, we give it two values and it returns the smaller of the two. Absolute returns the absolute value of the parameter, so the absolute value of -2 will return the value of 2. The absolute value of -2.1 will return 2.1. Random, it will return a random double in the range between 0 and 1. If I wanted to return a random integer, then I will cast the value to int by writing between parentheses int and then math.random, and then I can multiply it by 10 if I want the value to be between 0 and 9, and I can also multiply it by 50 and add 50 to make this number between 50 to 99. So moving on to character data, when we type char, letter is equal to between single quotations A, this is the ASCII code of the letter A. And if we write char numchar is equal to 4 between single quotations, that is also an ASCII value. So anything we write between single quotes, it is the ASCII value. And we can also choose to write in Unicode. So Java understands Unicode encoding, and it also understands ASCII encoding. So if we wanted to write using Unicode, then every Unicode value starts from a /U and then some number. And Unicode allows us to extend the values in ASCII code. So ASCII code is 7 bits, Unicode is 16 bits. So it allows us to include more characters. And whenever we use an increment or a decrement operator on a character, it will move us to the next character. So char ch is equal to a. If I increment this value, then it will display the character b. So system.out.println ++, which is pre-increment of the variable ch, it will return the value of b. So as I said, Java characters use Unicode, which is a 16-bit encoding scheme, and it allows us to write text by preceding it with a /U. And it can also be expressed in 4 hexadecimal numbers, as we see. There is no example, but it tells you here that it can be expressed in 4 hexadecimal numbers. So, for example, here, if I want to write alpha, beta, and this variable, which I don't know the Greek letter of, it is not in ASCII, so the way to write it using Unicode, we will use this value for the first character, this value for the second character, and this value for the third Greek letter. So characters that are commonly used, for example, from 0 to 9, these are all numbers. The code value in decimal is between 48 to 57, and the Unicode values of those is U0030 to U0039. And the capital letters from A to Z. The code in decimal is from 65 to 90. The code in using Unicode is /U 0041 until /U 005A. And the same goes with small letters. So we also use escape sequences for special characters. So whenever we want to, for example, use some special characters, such as writing a tab in the text that we want to be printed, for example, typing a double quotation within a string, we need to use those escape characters. And we have a couple of them here. /B is a backspace, /T is a tab, /N will give us return a new line, /F is form feed, /R is carriage return, and double backslash, it will it will allow us to write a backslash. I've been saying forward slash and I mean backslash. So, and backslash quotation marks, it will allow us to print the quotation mark on the screen. So, casting between characters and numeric types. If I want to cast a character to numeric to character, it is very easy. We just write between parentheses int if I want to cast a character into an integer, or write char next to a number to be casted to a character. And we can also use them in comparing and testing characters. So for example, here we have an if conditional, as we've studied in part 3. We are comparing a character if it's between A to Z, capital A to Z, and we write it as CH is greater than or equal to A, and also it has to be less than or equal to Z. So it is between those two values. And then if that happens, then we'll type CH is an uppercase letter. Else, if it is between small letter A and small letter Z, then it is a lowercase letter. If it is between 0 and 9, then it is a numeric character. And we have some methods for characters, such as isDigit to tell us if this character is a digit, if it's between 0 and 9. IsLetter to tell us that it is a letter between capital A to capital Z and small a to small z. IsLetter or digit returns true if it is either a letter or a digit, not a special character, for example. IsLowercase tells us if the specified character is a lowercase letter, it will return true. IsUppercase will return true if the character was an uppercase letter. ToLowercase returns a lowercase of the specified character, so it will return a character that is the lowercase of the value that we have here. ToUppercase, it will return a character that is the uppercase of the character that we have here. So the string type, it is not a primitive data type. What is a primitive data type is char. The char type only represents one character. But how can we represent a string of characters? We will have to use a different type, which is called string. So for example, the way that we write it in Java, we'll write string with a capital S, and then the name of the variable equals to whatever string that I want to write. And then we end it by a semicolon. So string is actually a predefined class in the Java library. It is predefined. We don't have to create a string class. It is already there, such as the system class and the scanner class. The string type is not one of the primitive types, and if you can remember in part 2, we showed what are the primitive types. So we said that these types over here are all primitive types. You can see that string is not one of them. String is a reference type because it is a class. So the string type, it is not a primitive type. What we mean by a primitive type, it is the basic types. So the basic type that we create strings from is characters. A string is nothing but a collection of characters. So that is why it is a reference type but not a primitive type. We create a string by collecting a combination of multiple characters together, and we call it a reference type. So any Java class can be used as a reference type for a variable. Some of the simple methods for string objects, we have the length method, which tells us the length of the string, how many characters do we have in a string. Char at, and then we write an index. It will tell me what is the character at that index. Concat, and then here we have a string. It will concatenate the first string first and then followed by the next string. The ToUppercase, it will return a new string, which is the uppercase version of the original string. To lowercase, it will return a new string, which is the lowercase version of the original string. So if it had any capital letters, it will turn it to lowercase letters in a new string. It will not change the original string. The trim method will return a new string with the white spaces trimmed on both sides. So if I have white spaces at the beginning and the end, they will be removed. So here we have an example of using the dot length function. We have a new string, which is the data type, a variable named message, and we have the string welcome to Java, and we end it with a semicolon. So to print the length, we will use the method for printing, which is system.out.println, and then we enter the length of, which is what we want to print next to the length, plus message, plus is, and then plus message.length. So this will print the length of welcome to Java is, and then message.length. So converting string, this is an example of the conversion. So welcome, we have here a capital letter. To lowercase will return a new string with all lowercase letters. Welcome to uppercase, it will return a new string with all caps. Welcome trim, we have here a beginning and ending white spaces, and they will be removed in the new string. So simple methods for string objects. Strings are objects in Java and are called instance methods. We call them instance methods. So we have two types of methods in Java. We have instance methods and we have static methods. So this is the first type, and then non-instance method, we call them static methods. What we mean by that is instance methods, we refer to an object. So we refer to an object, which means that when we use the methods in string, we refer to the object that we want to use this method on. What this means is, for example, if we want to calculate the length of the object, the variable message, we will use message.length. So this is what we mean by instance methods. We use the variable or the object, and then within that object we use those functions or those methods. But a static method belongs to the class. So we don't refer to any variable, we don't refer to any object, but we refer to the class. So the way we write it is such as pi. So pi, where did we use pi? Okay, so here, when we're using pi, we didn't refer to any object, we referred to the class. So this is a static variable. And for example, this method is a static method because it uses sign with not a variable. This is not a variable, this is the name of the class. So this is what we mean by a static method and an instance method. We'll look into that in more detail in upcoming lectures. So the static method can be invoked without using any object, without defining any new variable. We just call the class name dot and then the name of that variable, such as pi or such as sine, cosine, without creating any new objects. All methods defined in the math class are static methods. They are not tied to any specific object. So now we'll talk about how we can convert strings to numbers. So strings are a little bit different than characters. Characters, it's easy by only casting. We can convert from a character to a number and a number from a character. But when we're dealing with strings, it is a little bit different. We have to parse an integer. So if I have a string and I call that string int string, and that int string has the value of, let's say, 58 as a string. So to convert this string, we need to parse it because it's not as easy as just converting one character. We are dealing with a number of characters. So we have to use a function. If I wanted to convert it to an integer, we will use integer class dot parse int, which is the method that we'll use to convert this into an integer, and then between the parentheses we'll enter the name of that variable. So this will convert the 58 into an integer, and I wanted to store it in an int value, and of course we define the data type as int. If I have a double, I'll do the same, but instead of using the integer class, we'll be using the double class, and we will parse the double. And here I'll have the double string, which will store a double. So for example, let's say 8.5 as a string will be converted into a double. So it will be, after parsing, after this, it will be only 8.5. And then to store it, I will store it in the double value, which has the data type of double. So to show you this in NetBeans, so let's say we have a string, and this string I will just write st as a variable name, and it has the value of 58 as the example. So if I want to turn this string, this is a string, if I wanted to turn it into a integer, what I'll do is I'll create a integer variable, and I'll call it, for example, value, val, and it will be equal to integer dot parse int, and then I will parse st. So now what happens here is that st, which was a string, it will be stored in the val as an integer. It is not a, the val here is not a string. Okay? I can run it, but the value will be the same. It won't show anything, but just to show you that it's not crashing. So here we get 58. What I can show you is that, to prove to you that it's an integer now, is that I can add it to another number. So 58 plus 3, and it will give us the result as 61. If it was a string, it will not add the two numbers together. Let's see if I add st, which is a string, to 3, it will not add them together. It will concatenate them. So that proves that here, in this example, we are converting it into an integer. So what happens if we didn't enter an integer? So let's say, for example, I entered f or g. What would happen? Our system would crash. So we have to be careful. We have to make sure that the string that we parse into an integer has to be a real integer. What about the other way around? Let's say I have, for example, a integer here that is called val, and I give it the value of 5. How would I turn this into a string? Let's say I want this to be a string. That is very easy. The string will be just by typing the val plus an empty string, and it will turn it into a string. So now converting it into a string, I'll just need to write string st, for example, is equal to val plus, and then an empty quotation. So this will turn val into a string. So now val is converted into a string. It's no longer, the value in st is not an integer. So this is converting from a string to an integer or a double or a number, and this is the other way around. This is from a number into a string. So if we want to get characters from a string, for example, if I have the message here and it says welcome to Java, I use the method message.char@, and I write 0, which is the index, it will return W. If I write message.length, it will give me the last index plus 1, so it will be 15. Message.char@14 will give me the last character. So try this out. What will be the output of this code segment? Pause the video and try to answer this question. So the first character of the message, welcome to Java, should give you a capital letter W. String concatenation. If I want to concatenate two strings together, I have two ways to write it. I can write string1 dot concat string2, and this will concatenate the two and store it in string3, or I can simply write string s3 is equal to s1 plus s2. If we want to concatenate more than two strings, that is also possible. We'll write string message, and it will equal to the 3, 4, 5, or whatever number of strings that I want to concatenate. So here, if we have an example, we want to concatenate chapter with the number 2 and store it as a string. We will use string data type s is equal to chapter 2 plus 2, and this will store it as a string in the variable s. And here it will concatenate supplement with the character b and store it as a string in s1. So now if we want to read strings, we've discussed before how can we read numbers. We've used input.nextInt, input.nextDouble. If we wanted to read strings, we will use input.next, and this will read the next word. So if we wanted to read the next 3 words and store them in 3 variables, we will create 3 variables, string 1, 2, and 3, and then we will equal input.next, and this will allow the user to enter the first value and store it in s1, and then the user will enter the second value, which is also a word, and store it in s2, and the user will enter the third word and store it in s3. And then to print those values, we'll use system.out.println. S1 is, and this will print the value of S1. S2 is, it will print the value that was read from the user in S2. And print S3 will print the third value as S3 is, and the value that was read from the user. So, reading a character from the console. As we've said, to read any number of characters or any words, any numbers, we always need to add a new scanner. We have to create a scanner and give it a name, and then we will continue the syntax by writing is equal to new scanner, and then the file that we want to read from, and we want to read from the keyboard. So it is not a file, it is not a database, it is from the keyboard, so we will write system.in. So here again, we will have to write the same statement, and then whenever we want to use it within the program, we will use the object input, and depending on what we want to read, we will use either next, next line, next int, next double. So for here, for example, we used next line, which means it will allow to enter a string of characters. So we will store it in a string, and we call it s, and then it will allow the user to enter a full line until they press enter. So to get the character at the first index, we will write char ch is equal to the string s, char at index 0, and it will store the first letter in that string. So then we can print the character entered is plus the character. That will return the first character that was entered by the user. Now if we want to compare strings, comparing strings, we can use the equals method, and we compare two strings. And for example, if here we have string 2 dot equals string 1, it will compare the two together, and it will return true if they are equal. If they were not equal, it will return false. Equals ignore case is the same as equals, but it will ignore the case, so it is case insensitive. It will return true if the letters are the same. It will return false if they're not the same. Compare to returns an integer. So the first equals and equals ignore case, it will return a boolean, either true or false. Compare to will return an integer. It will be, that integer will be greater than 0 if the first string is greater than the second string. It will return 0 if they are equal. It will return less than 0 if the second string is greater than the first string. Compare to ignore case will do the same as compare to, but ignoring the case, or case insensitive. Start with, and then prefix, it will return true if it starts with the prefix that I choose here. It will return false if it doesn't start with that prefix. Ends with, then suffix, whatever I choose to write here, if it was the end of this statement or the end of this value stored in, for example, S1, then it will return true. If it is not, it will return false. And we can also obtain substrings by using substring begin index to give me a substring that starts from, for example, index 2 until the end. And we can also choose substring with a begin index and an end index. And the way that it processes it is like this. It will take the first index inclusive and then the end index exclusive. So if I write it from 0 to 5, it will include 0 but not 5, up to 4. So here we have an example. For example, here we have a variable message which includes welcome to Java. The message variable dot substring from 0 to 11 will take all the values from 0 up to 10, exclusive of 11. So it will include welcome to and then space. And another example of message substring, we can write message substring 11, and it will start from 11 until the end of the string. So if I wanted to find a character or a substring in a string, I can use index of and then enter a character. For example, if I enter the character of A, it will check for the index of the first occurrence of the letter A in the syntax. If the character is not included in that string, it will return -1. And we can also include index of a character, and then I can give a from index, a beginning index of my choice, instead of the beginning of the string, and it will search for the first occurrence of that index starting from the from index location in that string. And I can also use index of s, and it will return the index of the first occurrence of the string s in the string. So I can write here a substring, not only a character. For example, here it would be character C, here it could be CH. And I look for the first occurrence. Index of a string with a starting point, it is similar to index of, but with a string instead of just a character. Last index of will start from the end of the string. It will start from the last index. Last index of with a from index, it will start from the last index. Here we choose a character, for example, the character A, and we can have a from index. So it starts from a certain location. last index of S is the same idea but with a string. Last index of S with a from index is the same idea, but we have a from index. And int k, which is the index of the string S at the empty space. So the string is Kim Jones, so the index S, or what we'll store in K, is the index of the empty space, which is 3. And we can also store the first name, which is starting from S, which is a substring of S from the beginning until we reach the empty space, which is K, the index of that. And the last name will be string last name is equal to the string S, which includes the full name dot substring from the index K until the end. And because we don't want to include K itself, we will start with here with K plus 1. So we will move one location after the index. So this will be the first substring, the first name, and this will be the second substring, which is the last name. Formatting output. We use printf to format our output, to print our output nicely. And the way that we use formatted output is by using system.out.printf, and then here we write the format, and then here we write the items or the variable names. So the way that we write the specifiers of the format is by using a percentage sign. So for example, if we wanted to format a Boolean number, we will use percentage sign B, percentage sign C is for a character, percentage sign D for a decimal integer, percentage sign F for a floating point number, percentage sign E for a scientific notation, such as this one, and percentage sign S is for a string. So that the way that we write this is, for example, we have an integer count, we have a double amount, and we want it to be formatted. So the way that we write it is system.out.printf, and then we write count is, and then the percentage sign D, which indicates that here I want the first integer to be assigned to this location. So count is this, will be located here when the text is printed, and then an amount of F, which indicates that here we'll have a floating point, which is the second item. And then when we close the parenthesis here, we use a comma, and then we include all of the variables or all of the items. In this activity, you can try to think of what would be the output of this code, and then here you can record your answer. So first you have an integer x, which is equal to 20, a float y, which is equal to 5.5, a character c, which is equal to capital letter J, and a string str, which is equal to hello Java. And then it expects you to print the output of system.out in a formatted string. Printf is equal to the formatted string as the following. So pause the video and try to see what would be the answer here. So here it is expecting a decimal number, so it expects x to be the first decimal, f to be the float, and then c, which is the character, and then s will be the string. So this will print the formatted string in this way. So we can see this in NetBeans. So it just doesn't recognize the spacing from the slides. we changed it. And now if we run the program, it will give us the formatting as we expect. So it should print first 80, then 5.5, and then capital J, and then hello Java. And it wrote it in the way that we expect. So in this second example, and here it shows when the formatting is most important. So if we have here two floating point numbers with many decimal places, such as A and B, and we wanted to print it with a format such that we don't use all of those decimal places, but we only want two. So in that case, we will print X is equal to percentage sign dot 2 if I want two decimal places, F, and then another line or a next line, B is equal to a percentage sign dot 4 F, which means we'll take 4 decimal places after the decimal point. So here, just to not have you confused, X we mean by A, but it doesn't matter in printing, whatever you choose to have it. And it should print 35.55, and in B it should print the decimal 40.1245. So if you run this in NetBeans to check the result, we will see the result that we expect. So we see that A has 2 decimal points, and yeah, it rounds the second number. So if I want 2 decimal points, it will give me 2 decimal points. But what happens, because here we have an 8, it will round it. And in the B, we have 4 decimal points, 1, 2, 4, and 5. But because the next adjacent number is 4, we don't round it. So it is the same as we do it in our maths. And this is just a summary for all that we have studied in this lecture. I hope you enjoyed this lecture. Thank you.